So this is the second example for normal stress. So in this example we need to determine the diameter of the steel wire when we want factor for safety to be 5 and the yield strength of the material is 600 megapascals. So this is the wire. This is the one which we are calculating. So we have to decide, we have to calculate what is the required diameter for the wire. Okay. So firstly, let's start from the formulas which we are going to be needing for this task. So once again, the factor of safety, so N is sigma critical divided by the sigma allowed. Okay, and in this case, now this is again yield strength of the material, so the wire in this case, and this is the maximum stress in structure. So now in this example, we already know the N. So N is given, it's 5, and we know the yield strength of the material, which is 600 megapascals. Also, we're going to be needing the formula for normal stress. So the sigma normal stress is the normal force divided by cross-section area. Basic formulas. So now we have them there. In this formula, newtons per millimeter squared. Just to remind you, a really important thing on this course. So now we can calculate from the safety factor formula, we can easily calculate what is the allowed stress on the structure. So the allowed stress in the structure will be sigma critical, so 600 megapascals divided by the safety factor of 5, and from there we get that the maximum allowed stress in the structure will be 120 megapascals. Okay, so we know that we have to design the structure so that the maximum stress in the structure will be 120 megapascals. So what do we do next? Well, it's the free body diagram. So we have done this before. Free body diagram, FBD. Okay, so in this example, let's draw it in here. In here. So let's make it like this. Okay. In here, at the end in here, we have the external force, like so. Then we have a point in here. I use red color to highlight this. And then we have a point in here. Okay. In here, we have the force from the wire. So F wire, like that. It has an angle, which we can easily calculate. Angle alpha. And then in here, in this point, we have support reaction that way, so vertical, and then we have reaction here in horizontal direction, that way. Let's call these F, A, Y, so force in point A to Y direction, Y, and then let's call this one F, A, X. So force in A point to direction X. The external force, well, the mass in here was 1000 kilograms, so the external force F equals to 1000 kilograms multiplied by 9.81 standard Earth gravity meters per second squared. So quite simply 9,810 newtons, like so. A little bit about the dimensions in here. So we're gonna need these dimensions. So the length of this section was 1 meter, and the length of this section was 3 meters. So first let's solve the angle alpha. So the angle alpha will be Argus tangent 1 meter divided by 3 meters. Well, where do we get this? So in this assignment here, this dimension here is 1 meter. 1 meter here, and this is 3 meters, and this is the angle alpha. So it's in tangent, so Argus tangent will be 1 meter by 3 meters is the angle alpha. So from there we can easily get the value for the angle alpha, which will be 18.4 degrees. Like so. So now the next step, from the free body diagram we can easily solve the forces in horizontal and vertical direction. And now we're gonna do all the basic 3 equations. So sum of horizontal forces, vertical forces, and the sum of moments. So you remember this from the mechanics. So sum of horizontal forces has to be equal to 0. Sum of vertical forces has to equal the 0, and the sum of moments has to equal to 0. Okay, and the moment we are going to calculate over the point around the point A in this example. So let's start with the horizontal ones. So we have FAX, it's pointing in our positive direction, and then we're going to reduce from that one the horizontal component of FW, which is FW multiplied by cosine 18.4 degrees, and this has to equal to 0. And then let's do the sum for vertical forces. So we have FAY in positive direction, FAY, and then we reduce from we add to that one the vertical component of FW, so it's FW times sine 18.4 degrees, and that has to equal to 0. And finally we can do now the equation for the moments. So when we chose the point around which we calculate this to be the A, that means that the FAY and FAX will go, they don't have any moment because they run through the point, so therefore we chose this point. So it makes it possible for us to solve this equation properly. So now we first take the vertical component of the FW, which is creating moment. So FW times sine 18.4 degrees multiplied by the length by the distance that the FW is from the point A, which is 3 meters, like that. And then from that we reduce the moment caused by the external force, so that will be the F times 4 meters, and that has to equal to 0. And now from, let's number these equations. So this is equation number 1, 2, and this is number 3. So now from the equation number 3 we can solve the FW, and the FW will be F times 4 meters divided by sine 18.4 degrees times 3 meters. The meters get subtracted away, like so. And since we know the F, which was 9,810, so we know the F, we can easily solve that the value for the FW will be 41,438 newtons. So that is now the force which will be in the wire. And now the task was to calculate what is the required diameter for the wire in order to get the safety factor to be 5. And now we already previously calculated that the maximum stress which we allow in the wire is 120 megapascals. So from the equation of normal stress, so the sigma is N divided by A. So now we know that the sigma must be 120, or it can be at maximum 120, and the normal force is 41,438. So from this equation we can solve the A. A will be N divided by sigma, and in this example the A will be pi times radius squared equals to 41,438 divided by 120 megapascals, so newtons per square millimeters. And that is, now we can, from this equation we can easily solve for the R. So the R will be 41438 newtons divided by times pi, and the entire thing inside square root, like so. And from there we can solve the radius, which will be 10.49 millimeters. So the diameter, required diameter of the wire would be roughly 21 millimeters. So that's how you will solve this assignment. Thank you.